You have learned that for similar solids, the ratio of their volumes is equal to the ratio of the corresponding sides cubed. But do you know why this is so? Let's find out by taking a closer look at this cube A with length, width, and height, each 3 centimeters long. Now suppose we double the dimensions of the cube, meaning the length is increased to 6 cm, the width is increased to 6 cm, and the height is also increased to 6 cm. Notice we actually obtain an enlarged cube. Let's call this cube B. In fact, cube A and B are similar because each corresponding side of the larger cube is increased 2 times. In other words, the length of each side of the larger cube is scaled by a factor of 2. So how many times larger is the volume of cube B to that of cube A? Well, one way is to find the actual volumes of the cubes. But do we really need to do that? Remember, each of the sides was scaled by a factor of 2. So the volume of cube B is actually 2 times 2 times 2 times larger than the volume of cube A. In fact, each of these here represent the scale factor, and the scale factor also represents the ratio of the corresponding sides. And since we're multiplying the scale factor by itself 3 times, the ratio of volume B to that of volume A is equal to the scale factor multiplied by itself 3 times, which is just the ratio of the corresponding sides cubed. In fact, this also works for other similar figures, such as a cuboid, for example. This time, let's scale each of the dimensions by 1/3, meaning the length is reduced to 2 cm, the width is reduced to 4 cm, and the height is reduced to 3 cm. So how many times smaller is the volume of B to that of A? Well, since the length of each side is reduced by 1/3, this means the length of each side of the larger cube is scaled by a factor of 1/3. The volume of B is actually 1/3 times 1/3 times 1/3 times the volume of A. Like before, each of these here represent the scale factor, which also represents the ratio of the corresponding sides. So we can easily rewrite this expression by replacing the 1/3 with the ratio of the corresponding sides. And notice, we are multiplying the scale factor by itself 3 times, so the ratio of the 2 volumes is equal to the ratio of the corresponding sides cubed. Are you now convinced why the ratio of the volumes of any 2 similar solids, be it a cube, a cuboid, or even a cylinder, is always equal to the ratio of the corresponding sides cubed?